Okay, what's happening? Today we're going to do lab exercise 4, Introduction to Structured Query Language. So, first thing you want to do, download the file LX4 from Blackboard. What we're going to do in this exercise is we're going to demonstrate creating queries using SQL code basically instead of the query design wizard. So, first one we're going to do is this simple format. Okay, we're going to do select star from customer. So the star here, this asterisk is a wildcard character. Basically, it means we're going to select everything from the customer table. And notice we haven't specified any matching criteria. So if the record is there, we're going to retrieve it, and we're going to retrieve all fields of it. So what we can do, go first to create and query design, and we're just going to drag in the customer table so it's available to us. And then we can write in the code. Okay, select star from customer, and we run that. Boom. Okay, we got the full list of 14 customers. If you want to go back and check, see if that is correct. Yep, 14 customers. We got them all, and we're showing all fields of them as well. Okay, so let's save this one. We'll call it SQL Query 1. Okay, and leave it be. Okay. Now, next one. Oh, by the way, if you open this up in design view, you'll notice the weirdness that there are no field specifications down in the lower part, right there. But since we haven't specified that any restrictions, any constraints, it's simply going to display everything from the customer table. But all these fields down here that we've been working with before in the design view, they're all empty. Kind of strange the first time you see that. All right. So 4 things you should know when writing queries in SQL. First of all, in general, any white space or blank lines between code aren't going to affect the query operation, right? So if I, for example, put a couple spaces here and some spaces here and some spaces here, it would run the same way. All of that white space would be ignored. Second thing, if you have multiple fields, right, or multiple tables and you want to select them, for example, last name, first name, what you do is separate them with a comma. Okay, then the system knows what you mean there. This means show last name and first name from all records in the customer table. And what else? Wildcard character means everything's shown that. One thing that you'll see if you actually go back and look at some of the queries you've written and you look back at them after you've saved the table, what'll often happen is Access will have added brackets around fields or semicolons at the end of whatever phrasing you're using. Mostly you can ignore that. It's a translation issue that Access expects to find the queries written in a certain way, and it generates some code to make sure that that happens, some extra characters. Okay. Now, the next thing we're going to do is write a query with the where command. So where specifically refers to the constraints, right? The matching criteria. So suppose we wanted to write a query where we're looking at the customer's last name and first name for each record from customer, but we only want to show the records where customer zip code matched 60101. Then we would write, just like in the exercise text, select customer.lastname, capital C, not that it matters, but I like to be consistent. First name from customer where customer.zip code equals 60101. Okay, we take that. Let's create a new query in query design. You know what? I'm just going to go straight to SQL view. We're going to copy all that in and run it. Boom, and it does that. Okay, you actually don't even need to drag any tables over. I just like to do that sometimes. Okay, if we look at the design view, okay, you'll see all the fields are down there. We're displaying last name and first name of customer. The criteria zip code is 60101, but it's not being shown. The zip code itself is not being shown. Okay, so we close this one out, save it as SQL Query 2. Okay. There are a bunch of different relational operators you can use for matching. For example, some of these we've seen, but greater than or equal to for greater than or equal to, less than or equal to for less than or equal to, and this, right, the 2 comparators for not equal. Also, important point, if you're talking about numbers, you just write down the numbers, but if you're talking about a text match, the text should be enclosed in quotes. because that way, you know, Access knows, oh, you're not talking about a number, you're talking about some kind of text string. Okay, next one we're going to do is queries involving the distinct keyword. So distinct shows all the records that match uniquely, in a sense. So for example, if I run a query with the zip code being distinct, it's only going to show all the different ones that those zip codes from that table. So we're gonna check that out. So we're gonna once again make a new query in the design view. We're just gonna go straight to the SQL view and we're gonna type in this code. We're gonna do select distinct zip code. All right, so that's gonna grab every time there's a different zip code in the table, it's gonna show that value from customer. So all that's going to do, it's going to look through the customer table. Every time it finds a unique zip code, it's going to include that to the list of query results. So I can run that and boom, it displays those 5 zip codes. And if you look through the table closely, you will find that those are the only 5 ones there. Okay. Anyway, we'll save this one as SQL Query 3 and leave that. Okay. Now, suppose you want to do queries with multiple constraints. For example, where the customer's number was 1 and the date was 11/11/2016. All right, so we'll do this. We're going to display some different fields there. So we'll select customer, date, item, and quantity, right, which are all there in the purchase table. So from purchase, and then where customer number equals 1, and the date equals, okay? Just like strings are enclosed in quotes, dates are enclosed within these pound symbols for dates. So I take that, create a new query, query design, hop straight into the SQL view, paste that code in, run it. And boom, I get the one transaction that happened on 11/11/2016. And if I look at my purchase table, it's pretty small, but I can scan through, yep, that's the only one that happened on 11/11, and it found it. Okay, close that out, save it as SQL Query 4. Okay, gonna do a couple more, right? So we're gonna do some alternative ones. Like suppose we wanna do an OR command, all right? So you don't have to save these in your file, but I'm just gonna put them in here. Okay, so straight to the query design view. And then in the text we have here all the same stuff, but instead of an and, we're gonna replace that and with an or. Okay, then we would show extra ones. So in here, we're going to do pop into the SQL view, just paste that in, run it. Hey, look at that. Now we got 2 matches, right? So if we're showing any of the records where either the date is 2016 or 11/11/2016 or the customer number is 1, well, we're getting an extra match where the customer number is 1. Okay, another one we can do if you want to show ascending or descending sorted results, we're going to do here, all right, select item and customer from purchase. If I can grab this stuff. Item and customer from purchase, order by, all right, so I'm just going to show all of them, but I'm going to order them by item DESC for descending, and then customer ASC for ascending. What it's going to do, it's going to find the highest number item, and for that highest number item, show all the customers involved in a purchase of that item. Then the next highest number item, and show in ascending order, you know, 1, 2, 3, all the customers who maybe bought that. Okay, so I'm going to take this, and in our fake query here that we're just messing around with, not really going to save, I can include that and run it. And if you look close, you'll see the item number is definitely descending rather. And within each group, the customer is ascending. So here we have 2 entries for item number 5, and the customers are 5, then 8. And we have, well, these 2 guys, they don't matter, but this one does. All right, so that's all the stuff. Little intro to some simple commands with SQL. Of course, SQL is a far more complicated language than this, but it's pretty easy to learn if you want to. Anyway, hope this was interesting and helps you out with your assignment. All right, we'll see you next time. Bye.